All right, we are ready to start week 8. And this is the first homework assignment. And it has just two types of problems. It'll bounce back and forth between the two. And so I just picked one of each. So for number one, the problem's just asking for you to find the extrema or the max and min values. Sometimes it'll give you an interval and sometimes it'll just say find all. So I picked one where you find all, but how you do the work is the same. Just keep in mind if they give you an interval, you just have to check your answers and make sure that they're in that interval. But how you do it is the same. So we're just going to go through those steps. So when you're finding max and min values, that really only involves the first derivative. So number one is to keep in mind what you're looking for and how you get it, and not to do extra work or use stuff that isn't necessary. So I'm going to find just the first derivative to find those critical points to be able to find the maximum and minimum values. So first derivative of negative 2x is just negative 2. And then the derivative of a natural log is just 1 over that value. So it's 1 over 4x. But there's this 3 here that's going to stay on the top, the numerator, over 4x. But then the chain rule says I have to take the derivative of that 4x. And so that's going to multiply by 4. And then, of course, you'd multiply that together to get 12. And then to find the critical values, we need to set this equal to 0. So when I solve this, I'm going to add that 2 over to the other side and multiply those together. So that's going to be 12 over 4x equals, and then when I move that negative 2 over, that would be a positive 2. And I'm going to put that over 1. And then I'm just going to go ahead and cross multiply here and do 8x equals 12, and then divide by 8 and reduce. And so I would get 1 and only 1 critical value of 3/2. And then I don't need to find the second derivative because this isn't asking about concavity. And so don't go that extra step on this one. And then as you're probably aware by now, I like to do a number line. But if you want to do more like a table of values where they kind of go up and down the left side, that works too, however you want to do it. And I only need to test this in the first derivative to figure out where it's increasing or decreasing, because that's going to help determine if it's a maximum or a minimum value. And that's what we're looking here. So just to the left of 3/2 would be 1. So I'm going to test 1. And then just to the right of 3/2 would be 2. So I'm going to go ahead and test 2. And I am going to plug those into here, into that derivative value. That's another important thing, is not to plug it into the wrong spot. I'm not looking for the y values. I'm looking for the derivative where it's increasing and decreasing. So I'm going to plug a 1 in here. And so that would be 12 divided by 4 is 3, and negative 2 plus 3. So that would give me a positive value. And I'm going to put in 2. And so that would be 12/8. And so a negative 2 plus a 12/8, which is like a 1.5, gives you like negative 1/2. So it would be a negative value. And then I like to just draw a picture just so mentally I know what's going on. So over here on the left, it's increasing. And then over here on the right, it's decreasing. And what that means is that this value is a maximum value. And so on Newton, it's going to ask you to fill in a box for the maximum value. And it's going to ask you to fill in a box for the minimum value. And we do have a maximum at 3/2. But on this one, there's no minimum, and so you would just enter no solution there. And if there's more than one maximum, you would just separate that with a comma. And sometimes you'll get both, but it doesn't matter. You just use those critical values and do exactly the same thing. So the steps are always going to be the same. So that's the direction every time it says this. So anytime you see that, just follow those same steps and do the same thing, and you'll be just fine. And then the only other type of question that's in this first assignment from week 8 is when it asks you to find where it's either increasing or decreasing. So it's going to have one of those two words, and then it'll ask for either concave up or concave down, and it'll be a mixture. It can be any combination of those. And so this one asks decreasing and concave up and down. Decreasing and increasing is going to come from the first derivative, and then concavity comes from the second derivative. So that's your clue just when you read the question that I need both on this one. So in order to do this problem correctly, I'm going to have to find both the first derivative and the second derivative and find the critical values from both. Okay, so let's go through those steps. So we're going to find the first derivative, and this is my favorite when they do this because when you bring the 4 down front, it cancels. So that it would just be an x cubed, and then when you bring the 2, it cancels, so that would be minus 75x, and then that would be minus 250, and then the derivative of a constant is just 0, so that goes away. And I'm going to leave just a little bit of room here so that I can factor it and find those critical values. And then I'm going to find the second derivative because that's how we're going to figure out if it's concave up or concave down. And so again, derivative of this would be 3x squared. And then that would just be a minus 75. Okay, now sometimes this is easier than others. And I actually picked one here where it's not that easy. And that's why I left some space because factoring this is a little bit tricky. It's not a squared, and so you can't just do a regular trinomial factoring. There's also not 4, and so it makes grouping a little bit trickier. There's lots of ways that you can do this, but the easiest, I think, is just to use your rules from an Algebra 2 type class and just do synthetic division with factors of 250. So what I did is I just tried 5 and negative 5 right off the bat. So I'm going to do a little synthetic division here, and I'm actually just going to put negative 5 in here. And if you don't know synthetic division, and it's kind of cool, look it up, or you can do long division, or if you know another way, then that's fine. So I'm going to just take the leading coefficient off of that, and then there's no x squared value, so I need to put in a 0, and then I'm going to put in a negative 75, and then a negative 250, okay? And then I'm going to put my little line here, and again, if you're not familiar, synthetic division is pretty cool. So you drop down that first, and then multiply, so that's negative 5, and then add, and then multiply, so that's a positive 25, and then add, and then multiply is a positive 250, and then add. And because you get a 0 here, that means that this was a factor. And so when I go to factor this, that's going to be one of my solutions, which gives me a factor of x plus 5, or a critical value of x equals negative 5. So that's my critical value. And that's how you would write it as a factor. And then this is kind of like what's left. And so that would be an x squared. And that would be a minus 5x, and that would be a minus 50. Okay, and then this is where I got a little bit happier because this at least factors a lot easier. So that's an x and a 5 and a 10, and then that would be a minus and a plus. So then I have 3 factors, x plus 5, x plus 5, x minus 10. These give me the same critical value of negative 5, and then this one gives me a critical value of x equals 10. And those are the critical values that come from the first derivative, which is going to help me with increasing and decreasing, but I need to go one more step just to make sure I don't have any more that I need to worry about for where it's concave up. Because remember, only the second derivative is going to give you those little inflection points that you might miss if you don't do it. So this one factors a little bit easier. I can pull out that GCF of 3, which leaves x squared minus 25, and then that would factor into an x plus 5 and an x minus 5. And I already had that critical value of negative 5 there, but this gives me one more of x equals 5. And that, I think, is important to remember, is that we need both because we need to make sure we're not missing anything here, okay? And then I'm going to set up, my normal number line because that's just kind of how it works best in my brain, but you can do it differently if you want. And I'm just going to put these 3 critical values on there, and spacing doesn't matter at all. Get them in the right order is all that matters, but if they're not spaced out exactly right, it doesn't affect what you're doing at all. So I have negative 5, positive 5, positive 10, and then I just need to test values that are kind of in those intervals. So over here I could do negative 10, and then in between here is 0, and in between here, I don't know, 7 or 8, whatever you want, and then to the right of 10 is 15, 20, just pick something. And then because we're testing both, I need to test all 4 of these test points in both of these because I need to be able to answer both questions. And so over here on the side, I'm going to test it in the first derivative. And then I'm also going to test it in the second derivative. So this one takes a lot of plugging on your calculator. So when you're testing in the first derivative, you're going to go into here. And then when you go into the second derivative, you're going to go into here. And I get pretty good on my scientific calculator at just copying my equation down and changing the values and hitting equal rather than retyping it. For me, that seems a little faster, but however you want to do it. So when you test these four values into the first derivative, you get negative, 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 positive, and I would love for you to practice that and check my work. Don't just believe me. You learn math by doing math, so practice it. And then I'm going to take those same four test points, and I'm going to plug those into the second derivative, and you will get positive and negative and positive and positive. That was a little off center, sorry about that. And then we've got to answer the question. We want it decreasing, which means the first derivative is negative, and we want it concave up, which means the second derivative is positive. So which intervals have a negative first derivative but a positive second derivative? A negative first derivative but a positive second derivative. So that's this one and this one that I totally off-centered there. And then we want intervals. And so this interval, let's see, where can I write this? Right up here, maybe. This would be negative infinity to -5. And then also this interval from 5 to 10. And again, it's possible on these that they'll give you a range of values and they'll let you know, or a domain of values, I guess, to use for your X values. And if so, just make sure that these are all in that. But on this one, it just wanted to find all. And so that would be your answer. And that's what you would enter into Newton to get that one correct. And those are the two main types of problems from week 8, homework number 1. And I sure hope that helps.